Hey everybody, this is Unit 5, Formative 3. We're going to be multiplying radicals. This is our second day of doing this. So when we multiply radicals, main thing we want to remember is our distributive property. Okay, so these multiplying radicals are a little bit different than what we did the other day. Like I said, what you want to remember is your distributive property. So we have a square root of 5 on the outside of parentheses. We have a square root of 10 plus 2 square root of 3 on the inside. So like I just said, we're going to distribute. So square root of 5 times square root of 10 gives you square root of 50 plus square root of 5 times 2 square root of 3 gives you 2 square root of 15. Now the reason why it's 2 square root of 15 is because this 5 here will not get multiplied by the 2 because the 2 is on the outside, the 5 is on the inside. You cannot multiply things on the outside and inside together. If there was a 2 out here, we could take the 2 times the 2 and there would be a 4 here. But there's only a 1 here, so we took 1 times 2 to give us the 2. Okay, you can only multiply the 5 by the 3 to get the 15. Okay, now we're going to start breaking everything down. So 50 breaks down into, so now we're back to an addition of radicals problem, and in order to make sure you can't add them, we need to actually simplify them. So 5 times 10 gives us 50, and 10 breaks down into 5 times 2. So looks as though you have a pair of 5s, which means there's going to be a 5 on the outside and a leftover of 2. So 5 squared to 2. Okay, now we're going to break down 2 squared to 15. 15 breaks down into 3 times 5. And there are no leftovers, or there's no pairs. So 2 square root of 15 is as simple as that can get. So your final answer would be this right here. And you are required to actually simplify any radicals that you can. So if you would have left your answer as square root of 50 plus 2 square root of 15, it would have been partially wrong because you need to simplify the square root of 50 to 5 square root of 2. And I can't add these together, remember, because they're not the same radicals. Okay, that was in video 2 if you need to go back and rewatch that. Okay, so again, here we have another problem that's just like distributing. This was like a binomial times a binomial. So remember, everything in the first binomial has to be multiplied to everything in the second binomial. So we'll start with 3 square root of 6 times 3 square root of 6. Okay, well 3 times 3 gives you 9. And square root of 6 times square root of 6 is square root of 36. Okay, now we're going to take 3 square root of 6 times times negative square root of 11. Well, 3 times negative 1 gives you minus 3, and 6 times 11 gives you 66. Okay, then we're going to move to the bottom. Square root of 11 times 3 square root of 6 gives you plus 3 square root of 66. And then square root of 11 times negative square root of 11 gives you negative square root of 121. Okay, now we're going to look at this a little bit closer. If we look at these two terms right here, normally we would combine them together if we could. But in this case, we have negative 3 square root of 66 and positive 3 square root of 66, so they're just going to cancel each other out. So now I'm left with 9 square root of 36 minus square root of 121. Okay, now 36 is a perfect square, so in other words, it breaks down into 6 times 6. So at that point, you could break it down into 2 and 3, 2 and 3, so you have nothing. You have a pair of 2s, and you also have a pair of 3s. Okay, but you don't need to do all that if you recognize that 36 is a perfect square, and 6 times 6 equals 36, so the square root of 36 is 6. So in reality, this is just 9 times 6 here. And the square root of 121 is also a perfect square, and if we notice, we took 11 times 11 to get 121, so the square root of 121 is 11, so minus 11. 9 times 6 is 54, minus 11, so we end up with 43 is our final answer. So something as complex as this right here simplifies down to just 43. Okay, let's look at another example of one of those. 5 times 4 is 20. 5 times square root of 2 gives you positive 5 square root of 2. Remember, we can't multiply the 5 and 2 together. because one is on the outside of a radical, one's on the inside. Okay, then we move to the square root of 2. Square root of 2 times 4 gives you 4 square root of 2. Square root of 2 times square root of 2 gives you square root of 4. Or, at this point, if you can recognize that a square root times the exact same square root, or in other words, square root of 3 times square root of 3, is equal to square root of 9, which is also equal to 3, you can do that as well. So square root of 2 times square root of 2 is just going to be 2. Okay, any square root times the exact same square root will be the number underneath the radical. So in other words, square root of 4 times square root of 4 is just going to be 4. Or square root of 5 times square root of 5 is going to be 5. Okay, or so on and so forth. Okay, then we're going to combine our like terms. So these are our like terms right here. We have a 5 square root of 2 and a 4 square root of 2. We also have a 20 and a 2 that we can put together. So that gives me 22 plus, and then remember how we add and subtract radicals. We just take the numbers out front and add them together. So 5 and 4 gives us 9 square roots of 2. And the square root of 2 can't be simplified, so there's your final answer, 22 plus 9 square root of 2. And you don't take the 22 plus 9 because they both don't have square roots. So there is your final answer. Okay, and our last one here. Remember when anything is squared, it actually means square root of 7 minus 5 times square root of 7 minus 5. Just like when you were timesing binomials times binomials without square roots. Okay, so square root of 7 times square root of 7, what we just talked about on the last slide is just going to be a 7 because any square root times the exact same square root is the number underneath the square root. Square root of 7 times negative 5 is going to give you negative 5 square root of 7. And then we move to the bottom, so negative 5 times square root of 7 is going to give you another negative 5 square root of 7. And negative 5 times negative 5 is going to give you a positive 25. Okay, so you have negative 5 square root of 7 and negative 5 square root of 7. You can put these two together. They do not cancel each other out. They actually equal a negative 10 square root of 7. And then 7 plus the 25 is going to give you 32. And there is how you're going to multiply those two together. All right, and that is it for distributing your radicals. Make sure you guys took notes, and we will see you later.